We've got another great presenter coming up now for you, Dilyana Bossenz, who's at Viz Pilgrim on Twitter. Dilyana is a business intelligence consultant and she's based in Berlin. Her professional focus and also her passion is data visualization with Tableau. She is the co-organizer of the Tableau user group in Berlin. Fantastic city, by the way. I was over there for the Tableau conference earlier this year. Now, currently she's on maternity leave with her little daughter, but she's going to talk to us about visual encoding and addressing questions like, what is visual encoding? And how to encode data visualizations visually, with what are the elements of visual encoding and what is their hierarchy, and she'll give us some examples on Tableau Public. So everyone, please welcome Dilyana.
Yeah, my name is Dilyana, and before we start, I would like to point out some organizational matters. So this video will be recorded and you will find it as soon as possible at the YouTube channel of TFF. And this Tableau workbook you will find after this talk on my Tableau Public profile, and I'm gonna also write a blog post about this topic. So just follow me on Twitter or LinkedIn to get this update. I first came across visual encoding learning about data visualization and reading different books, even though I have been working or I have been doing data visualization for a few years. And visual encoding is some kind of basic in data visualization. And thus I would like to start my talk by quoting Nathan Yao. He is an author of different books about data visualization, and yeah, he said that learn the rules of data graphics so you can bend them. What that means? By learning something, you always do small steps. Like by cooking, you need to know what flavors work together and against each other before you cook. Or you have to learn grammar rules and spelling before you can write a paper. So the same is in data visualization. You need to know basic rules. And basic rules and visual encoding, it is actually a basic rules. Well, visual encoding, it is mapping from data displayed to, visual encoding, it is mapping from data to display elements. So you as a data visualizer, you encode data visually, and the viewer have to decode that information. And to know about visual encoding will help you to find clarity when you try to create something using data. And it also helps thinking about it logically and in a pretty structured way. So it means you are consistent in your work because you have some kind of rules. So those you can easily explain what you are trying to do to a reader. Let's have a look in one simple example. Yeah, that's better. Yeah, assume we would like to analyze discount and profit per country. So by the way, I just used for this example the data of Superstore in Tableau. So, okay, so I put discount to the x-axis and profit to the y-axis. And now we did our first encoding. Discount is encoded visually along the x-axis and profit is encoded along the y-axis. And I put also states into the details just for a better interpretation of the data. For our visualization, it means that countries that have received less or no discount at all have a higher profit. And for example, position is considered a planar variable because it locates points in space, and it is also display elements that we can perceive with a great accuracy. So position can be good for encoding two variables. But what we do if we would like to get more information about this visualization by adding third dimension, like here. Here I added sales to the size and get this graph, and in this particular case we use retinal variables to encode additional variable for this data set. If you said, wait, what does retinal variables mean? I would say I'll explain it in a minute and yeah, show some examples about this. So size is an example of retinal variables, and it is particularly good for order data. I can also put category on color and make this three categories recognizable, like blue stays for furniture, green stays for office suppliers, and red stays for technology. So I also encode category visually as a color. And yeah, in the last variable we need to address is time. I would like to animate this graph. So time is a not static display element like color in this case, or yeah, like color or size or position. So time is animated through individual frames in our visualization. So now you have seen one example of how map data to display elements, and we encoded our data visually as a position, a size, a scale, as an animation. And I would like also to show you another example. For example, this graph. And on this visualization, you see the beer attack in North America between 1900 and 2018. And here, for example, you see that months are encoded on the x-axis and number of beer attacks is encoded along the y-axis. And the number of beer type encoded as a color, so etc. I hope you get a point, and I just advise you to find a graph on the web and try to describe how this graph encoded visually, ask questions about data, so you will get the feel for how the graph is working. I already mentioned retinal variables. So with retinal variables, we encode information, just like size, color, saturation, color saturation, orientation, works very good for order data. However, it may be difficult to perceive quantitative differences using these visual encodings. The perceived values and differences between, for example, light blue and light blue isn't so obvious. So for this, just use this retinal variables like color, hues, and shapes. They are great for encoding nominal variables. Let's go a step further. And so we just learned what visual encoding is and how the data could be encoded. And this was our list of possibilities: angle, color hue, color saturation, length, orientation, etc. Let's just think about which of visual encoding most effective. How should we know whether to encode a quantitative variable in color saturation, or rather than say position And I found on the web a lot of information. And one thing what I really liked is the blog post of Nada and Yao. I put this link here so you can check it out. It is an excellent blog article according to this topic. Actually, he summarized a research paper of Cleveland and McGill, and the link to this research paper is here. So Cleveland and McGill, they studied what people are able to decode most accurately and rank them into following list. So we can encode information visually as a position, length, angle, and slope, area, and volume. But you can encode information more accurately with a position or length, and less accurately with a color density or volume. So yeah, McGill and Cleveland were trying to see with this kind of method how effective using coding were in terms of users being able to interpret quantitative information, that is exact numbers from the graphs. So for our visualization, this is why the most important variables, discount and profit, because they were encoded as a position. So, and it is because accurate of the bench. So key takeaway here is that if you want to design an effective visualization, then you need to understand the ranking of visual encoding and choose appropriate encodings in your design. Yeah. So now, before you go shining everything that isn't in the top 3, just keep in mind that this list isn't meant to be a definitive answer on what to use and what not to in your data graphics. Cleveland and McGill know that the ordering does not result in a precise perceptions for displaying data, but rather is a framework within which to work. So we saw now how we can leverage visual encoding to effectively represent and present data. So think of visual encoding as a building blocks of graphics, and these are components that we can combine in creative ways to construct a visualization, and an analogy can be drawn to how we communicate information through text. When writing an article, you construct sentences and narrative through using different parts of speech. So just try to think of the different visual encoding we just have covered, and yeah, as in nouns, verbs, an adjective of graphics. So yeah, this is it actually, and I hope you like this presentation, and as I already said, I will upload this on my Tableau Public. If you have some questions, feel free to ask me now or later on Twitter. However, yeah, thank you for your attention, and back to Fee.
Thanks, Dilyana. We really appreciate the great presentation. We have some questions. I'm just going to open the chat. So are there types of visual encoding which are more effective than the others?
Yeah. I tried to share my screen again in order to answer this question. So Yeah, here. Yeah, this is actually the answer on the question. If you encode information with a position, length, or angle or slope, so you are on the right track. So this is a good choice if you use these three ones. The other three, area, volume, and color density, it is not enough, so you have to add some other visual encodings to your visualization to make it more accurate in order your audience can perceive it better.
Cool. And what tips do you have for us that help people with going through and understanding if their visual encoding is working well? How do you guide people through that kind of coaching conversation?
Sorry, can you repeat it? I couldn't get it because of sound.
No problem. So what I'm curious about is, you know, when people are creating data visualizations, obviously they're using visual encoding in different ways. How do you coach people through a visualization and talk to them about encoding specifically and what they could do? What are your best tips and tricks?
Oh, okay. I get it. So first of all, it's all about the content and message, what you would like to say to your audience. And then for me, it works very well if I just look at my visualization and if I can find an answer on these questions. And usually these three things, position and length especially, it works very well if you talk about your graph, because it is some kind of general knowledge what everybody can understand and what everybody has. And just trying to explain with the small steps about position and length. And if you have some kind of advanced visualization, it will be a bit difficult, but you should also work with contact or with the legend, etc.
Okay, great. Thanks. There's no other questions that are on the chat or in the Q&A. So thank you so much for joining us, and particularly so early as well. We know that it can be really tricky with the different time zones. So thank you and have a great day.
Thank you too. Bye-bye.
Bye.